Hello everyone, this is another video from Easy Electric series. Today we want to design the control system with HMI that able to tell us how many empty spot is inside the parking. So we suppose we have a parking with the 5 spot available to park. For make that simple, so we want to have the HMI like this with 2 reset button. The first one reset the counter in the entrance, the other one reset the counter in the exit. So we have a total number of the car which is inside. We could actually see that number. On the right side, you actually have 2 indicators, full available. If there is any empty spot, the available should be on. If not, the full should be actually turned on. So for sure, we need 2 sensors. That's what you see here. We have in these 2 corners. This is for number 1. This is number 2. This is for a entrance and this is for a exit. So if you come back here and let to reset everything. So I reset the exit, reset the entrance. So now we have 0, 0. So I'm coming here for an entrance and just 1, 2 and 3 cars get in. So see here we have 3, 0 go out. So now I'm adding actually 1 more, so we have 4. So now whenever 5th come in, so technically we should actually turn on the full. That's what you see here. So I also have the exit here. So if you go 1 down, so technically now is available. Total car we have inside is 4. Now if I go and pass from the entrance sensor, let's do that. So I have actually 5, so there is no empty spot. As I say, the assumption is just 5 spot available inside the parking. So let's see how we could design these system in the HMI and also with the PLC. So stay tuned. So before I start to work with the software, just take a look to the hardware that we need. We have our PLC, we have our HMI. So we have 2 sensors. This is for exit, this is for actually entrance, and these 2 technically connected to the port 0 and 1 in our PLC. So all PLC, HMI, and computer connect to this switch that you see here through the cables that you see. So the first cable is for a PLC, second one connect to the HMI, and the third one connect to the computer. So let's go to the software and see how we could program that. Okay, let's see how we could design the control system for this parking lot. So we go to the create the new project. I put the path and also the name of the project I'm going to create it. Okay, it's open this window. We are going to configure a device. So for sure we want to add a new device for these control system or these projects. So let's start with the controller. So our PLC is this one. So I choose that and I add that PLC, which is unspecified CPU 1200. So it's going to be connect and somehow recognize the PLC that we have. So now we are going to detect it. So we need to see which one. Need to choose the USB and start to search. So now let's say detect, connect. So the password, so my PLC is password protected. Let I just give a password and go through it. So as you see, it's able to recognize that. So now I should see my PLC here, which is recognized, that correct. So this part is important, the security settings. So just make sure, because you are using the HMI, make sure you get rid of these protection checkbox, and here also get rid of these checkbox. So otherwise you could have a hard time to load the codes to the HMI. So you go next, and here is important to you make sure have HMI access. So then you actually go to the next and also finish. So if you have problem in that those windows that pop up, I explained them with detail in the previous video, which is the first HMI program. You could actually take a look to those video. So now we have our PLC. So we could add HMI, or first we could actually write the program. So let's first write our program on the HMI, then we could actually have or define the HMI that we have. So let's start with two counter and see what we need for these project. For sure we need actually one up counter. So let's go here on the instruction and the counter, and here find the count up, bring that here. So I'm actually put everything, yeah, this is everything is accept as a default. So this should be here. We need one normally open, and also on the reset we need normally open. So the next will be the same. I'm actually need another counter count up for a technically for a exit, right? One counter counting how many cars get in, and the other one technically counts how many cars go out. So let's just have another normally open there. So here you could actually give how many it's actually count. You could give 10 also. It goes more than what you have there. That should be fine for now. I just give 10. You could give any number. So anyway, even you pass the 10, it's counter able to go up. So shouldn't be a big deal which number you put there. So what else do we need? So let's just complete these two. So here we need actually our sensor 1, which is our sensor 1, which is entrance sensor connected to the I0. So here I say percentage I00, which is the entrance sensor. I rename the tag. The tag name should be reset entrance. Let's to say reset entrance, which is technically you use this to reset the value. Oh, sorry, not this is actually is not the right one. Let's to just this is actually the sensor, not the reset. Let's to just change that. So this should be this. The tag should be entrance sensor, entrance sensor. So you change it. So now this one should be actually the reset. So for this one, because we are using the push button there, it is better to give a memory. So let's say there should be M0.0 for this, and the tag number should be reset entrance, right? You could give a name that somehow reset entrance. It somehow reset the entrance counter that we have. You don't need to add anything here because this is already inside these system tools. If you take a look to the system tools and go to the program resources, so you could actually have the access to these bits that we are going to use. Technically, you don't need to save that inside any word memory. And the problem with putting the word memory, writing the tags from word memory to the HMI tags, it's make a lot of the problems. So that's what we prefer. Just use the database and the parameter that this counter actually has. So later on you will see that. For now, let's just say these two. Then we go to the next one, do the same. So this one should be still the sensor, should be the I01, which is technically is the second sensor that we have on the exit. Rename that and name that exit sensor. So exit sensor. So we change it, so we have that there. And this one, similar to the other one, this is just another memory bit 01 for resetting the counter that you have in the exit. So rename it. So I rename it to the reset. Let's say reset for an exit counter that you have. I change it. So now I have the both. So now for sure you need to subtract that two numbers that you know how many cars you have inside the parking lot. So that means you need to come here and maybe go to the math function and find the subtraction. So this is what we need. Okay, so look actually here and exactly see what I mean. So what I should do, I should have these current value of the first counter and subtract with the current value of the second one, right? So see how I get them. So I come here and choose, so see db1, db0 and d1. This is a counter 1. Let's see what it has. So it has one value which is a current value. I choose that. You don't need to put them inside the memory, right? They already is inside the counter table and you easily could use. So this one should be the second. Oh, actually I shouldn't click that. So let I delete them. So click there, go find the second one, and the second one CV, which is the current value. So as you see, the first one, the current value of the counter one, and somehow these are the data structure, right? Database of the each counter. Each counter has its own table, and you could find these all variable inside that, which is the current value is there. I easily could use them rather than I save inside the Word and use the Word. There is really no need to that. So writing exactly the memory to the tag of the HMI, it's actually makes a lot of problem and crazy things happen whenever you run. It is better to use these value rather than saving the memory, then actually you correlate the tag of the HMI with this memory directly. It's not actually right things to do in at least Tiva portal. So the out, so for out, technically we have no other option for out because this function doesn't have a database like that we could use out. So here I have to make a word, let I say MW0. So just make sure everything is cap MW0. So that means the subtraction is saved inside the word, which is a memory address, and we save the subtraction there. So I give a name for this word. So I say total car inside. Let's say car inside. After you subtract that, it's give you idea how many cars you have inside the parking. So now again here we have a situation, and the situation is if you go make a HMI tag and somehow connect HMI tag directly to MW0, this actually makes some problem here. So technically it's not the right things to somehow correlate or connect the HMI tags directly to the words. So what we should do, so you should use the move function. So let I come here and see if I find the move operator. So I found the move operator here and I actually put that there. So see what I'm doing. So I'm going to move these let's say percentage MW0. So inside actually one database. So what I should do, I should actually make a data block. So I'm going to here and say, see on the PLC there is a add new block. I'm going to add a new block. So it says data block 1. I'm fine. That's the global block. That's okay. I'm saying okay. So it's here. It does look like the data structure. You are making the variable, which is a data structure, and you could actually save everything inside that. I'm going to make an integer, and I call that car inside. And rather than directly connect the tag of the HMI to the memory, I'm going to somehow make a connection between the tag of the HMI and this data block that I made. So I say car inside, exactly the same name. So here is important. What should be the data type? Not Boolean, so should be integer. So I'm going to choose the integer here. If I could find that integer, whenever you subtract the number of the car should be integer value. So looks fine. So my data block has just one integer value. I call that car integer. I back here. Now somehow I move whatever I have inside the MW0 inside these data block. So if you go to here, this is my car inside. No, this is actually MW0. So I need to come, just be careful, don't put this here. I come to my data block, car inside. This is actually what we should do. I say enter. So this shouldn't be right. It's this, I'm not putting that on MW0. I did something wrong here. So let's just back to my data block, make sure everything is fine. Yes, I have it. So I actually put that inside these data blocks. So I'm going to somehow, yeah, maybe that was better to give the other name, but that should be okay. So see, it shouldn't be this one. This is MW0. I should choose this one, which is from the data block. Now it is right. So see what I did. So instead of using directly this tag and connect my HMI tag to this address, this is, as I say, is not the right things to do. I somehow move this value to the data block integer number. I call that car inside. Now I make a connection between HMI tag and this data block rather than connect to the address. As I say, is not the right things to do, and your program is going to do crazy things. So the next, we just need to somehow compare. So let's see what we have here for conversation, move program. Let's see what else we could move math. Yeah, compare operation. Let you open it. Equal, greater or equal. This is what we need. So we need this for saying compare with the 5, right? So the first thing is what we are comparing here is integer number. So what's the value? Our parking has the 5 spot. We should compare the subtraction with these 5. So if it's that greater, okay, I put here one normally open, and here we need another one, and here I'm adding some other operation here, probably not. Let's see what we have. Do we have any bit logic operation? We have it. I'm looking for a not here. I add the not here. So then we actually have another one. So that's actually, let's start with this, then I explain why I add those there. And should be, actually this is the wrong one. I don't need this technically. These should be the output. So I get rid of this, and these two output technically is for the available and full light, right? Yeah, for sure. Okay, what I'm doing here, let's go back and let's just add the output here, add another output here. We are good, and then we delete this one. Okay, so we are good. So let's go back here. We compare the subtraction. and that should be data block car inside. Am I right? So it's the same thing. You go to the data block, so then see which one. This is not the right one. This is a memory, so it should be this one. So data block car inside, which is a data block, and save the how many car I have inside. So it's compared that with 5. Is that greater? If that's greater than 5, what we should do, we should actually say this is full, right? So let's just have another memory here. This time let's say 0.2, and it should be the tag should be full, right? So I'm going to somehow rename that. This is a full indicator. I say full, and I change it. So here you are going to have the other bit indicator, and you say this is M0.3, and it should be, the tag name should be available. So this is somehow obvious. Whenever it is full, is never be available. So that means all the time these two should be not of each other, right? So whenever it is the full is on, available is off. Whenever available is on, full is actually off. So technically these two lights never could open or turn on together. That's why we actually use the not. Okay, so let's say available. So we change it. So looks we are actually fine. Let's run this program and make sure we don't have any problem here. So network 4 and 5. Network 4 and 5, what's the problem? Get rid of that error which says the data block 1 that is accessed has not been compiled. You just need to come here and find your data block, right click and say compile software. So you compile the data block, then if you back and compile the whole program, so it's actually somehow that error will be gone. So that means just data block, right click, compile first the data block, then you could compile all program, which I did. So now after you compile it, to load this and see if you could successfully load the program to the PLC. So the same thing show up, so you should somehow load that. So we did that before, so let's just load that again. So it asks about the password, give the password that you already have. So load it, and it should be go through, and you have all of them there. Yep, it's finished, and now we have our program uploaded. So now it's the time to somehow add the HMI. So we are coming here, say add a new device. So go to S712, not actually the controller this time. We are want to have our HMI. Our is for displays. So the basic AV, and here. So again, if you don't watch my first video about the HMI, go watch it. On that video I explained why you should choose the 15. So I choose the 15 because the version that I have on my HMI is 15. I explained this in more detail in the first HMI programming video. Please watch that. So I put on 15. So now I have my HMI is okay, I have it. So you just choose the PLC one. This is only PLC that we
have for this project, it is there. So the rest you just put the next. So if you want to customize, you could do that, but I just keep everything as a default and finish it. So now I should see the HMI. Okay, I have the HMI. So here, let's start with this one. Let's say welcome to, let's say, lab 11, which is this is our lab assignment that we have. So if you are interested to make that bigger, you could click on that, go to the properties, so you could find some adjustment for that. So I'm fine with that. So for saving the time, let's just have that there. So let's see what we need. We need two push button for technically the reset, right? So let's just have one here. I'm just typing reset in trans. So you could actually adjust the size to any size that you want. To see if we could, yeah, it should be fine. So I copy paste this somehow. I don't need to adjust to be exactly the same size. So this is two. So I change this for reset exit. So this should be good. So what else I need? I need actually the indicator. So which is see the number of the card. This is IO field. So I need probably 3 of them. So this is one. When you could copy paste. This is actually the second one. And we need a third one. So you could actually copy paste the takes or this one. So either should be fine. So bring that here and say number of the cars get in, that shows here. So then you just copy this, paste it, and have something here. Say the cars go out, which is somehow is a current value of the second counter that you have. So you could actually is here, and the subtraction. So you actually have the subtraction of those two, which is, if you remember, we call that car inside, right? So to say car inside. So you put that here, so as a car to inside. So almost we have everything we need. So you need actually two indicator. So one is here, and the second one you could copy paste. No, not this one. Yeah, I actually technically should copy this first. So I'm pasting that here. So we need, I don't know, you could have maybe something here or like that. That's up to you. Yeah, maybe this one is much better. So to put like this, take more corner. So copy these again. So paste them. This one should be full. Put that close, and this one should be available. You could say this one for available. You put that somewhere here, or even you could put that here, I don't know. Say full, and also this one is for available. Okay, so something like this. So now it's the time to somehow set up this. So back to here, the reset in trans, you go to the general text, so animation, yeah, it should be, yeah, footpath events, maybe, yeah, okay. So the most important one is here on the event press. So on the press, you go find the function, say all function is, take a look and find the one which is say set while the key pressed, so this one. So the tag number is important. So if you go to here for a tag, so you go on the PLC tags, the default tags, which one should be? Should be actually the intrans, reset intrans M00. So this should be this one. Just make sure you actually choose the right one, intrans, which is M00, and this is one is 0. So if you want to change the, I don't know, the color, maybe you comes here and say solid color. So then you choose something, I don't know, more fun. Something like this should be okay. So do the same thing for the second one, for a reset. Go to the solid. If you don't like the color, choose something more cool. Maybe this one. So then what else we should do? Go to the event. So again, not event, the tag screen number. Okay, so let's see what we did. So it should become here at the function and the same function. So set while pushing, again tag is important here. So what it should be PLC tags and should be reset exist. Am I right? So take a look, should be M01, which is a correct, and you choose it. So as I mentioned, having the connection between the memory M0 to the HMI tags is fine, but the word is not fine. That's what we use, that move function, we avoid that. So but for the just one bit, it's fine that you see I make a connection between the HMI tags and the PLC, just 1 bit memory. So we should be good here. So comes to car in, this is important one again. So if you go here and to see properties and see what we have in the general, yeah, is the general is a tag number. So this is important too. So see, this should be the current value of the, yeah, I go to the PLC tags and see what I'm choosing here. So let's see if we could choose the PLC tags, and yeah, so see, I go to the program blocks, go to the system blocks, program resources, I go to the ID, the first counter that we have. So now I choose the current value. That's important. If you again make a memory address like the word, then you put that here, so it gives you a crazy thing. It is better to exactly use whatever you have inside the counter. So same thing for this. So we go, yeah, I think I forget to put the output for this one here. After you put the tag, it is better to say this is just output, right? So same for the others. So you come here, so the same story, go to the second current, should be current value, right? Let's see, current CV, current value. Okay, that's a current value what you have there. So you say decimal and it should be just output. So this is should be fine. And also the numbers that you choose is just, I don't know, 2 or 1 should be enough, right? So you don't have to say 2 and 20 there. Okay, just double check, make sure we did right here. Yeah, we choose the CU. I think the CU is the wrong one, right? Should be the current value which is the CV. Let I double check that here, make sure we are choosing the right things. Okay, so let I just back to here and make sure we have, or we choose, yeah, should be the CV. CV is a current value. So back to here, let's say PLC tags, program blocks, not data system blocks. So DB0, I clicked on that. So it should be CV, current value, right? So that's what you have. Current value output decimal is fine. And even this is too much, let's say just 2 digits, so it should be fine. So now these two looks fine, so that one is fine. And let's say what is the car inside. So where car inside, again, just be careful. We have that inside our data block, right? So with data block, car inside is, okay, so see, if you tag this directly to MW0 or any word, it's do the crazy things. I did that, so it's really is not working based off what you see is just update. They shows the irrelevant number there, and also it looks like it's blinking there. So that's why I actually use the data block instead of the directly put the word connect to the HMI tag. So this is output and this is decimal. We should be fine, and this one should be 2 digit. It looks fine, so looks we are good here. Comes to this, and let's see what we should do here. So animation event, yeah, here should be animation. I know this option. So the tag here, yeah, this is actually the PLC tags. As I said, the M0 is not a problem. So this one should be the full. So see here, I directly connect the 1 bit to the tag of the HMI, which is that's fine. For a 1 bit is fine, but for a word is not fine. So here that's full. So you have 0, which is that color. Then you have 1, which could be any color that you like. Let's say red. So you do the same thing for this. So you say these options. So the tag is available. You say available. So you comes here, say 0 is this color, and this one, whenever it is on, maybe this green one is much better. Okay, so looks we are fine. Let's just click on this, and we also compile the file. So looks no error, that's a good news. Let's load it. So the same story happen here. We say load it and see what's actually we get. Okay, we say overwrite all and load it. So now something is going on there, and see. So now I uploaded everything there.
Okay, if you upload it to the HMI, this is what you see. So we actually see exactly the same thing that we had in the software. So let's actually go here, pass 5 card, get in and see what's happened. 1, 2, 3, 4, 5. So as you see, the red LED, the full indicator is on, so we actually see everything. 5 is in, 0 go out, and total car is 5. So now let's do just 1 cars go out and see what's happened. 1 cars go out, so as you see here, it's back to the available. 1 goes out, and total actually is 4. So again, if 1 goes in, again should be back to the full. So as you see, our system works.
Go to the online mode and you could actually check all of them. Let I just reset. I'm going to push the reset button on HMI and see is it working or not. Currently it is 10, and let's say this in trans, right? I actually push the reset button, so it's resetted and it's back to the 0. That's correct. So here you could come here and see the reset for a second one. So I reset it, so it's already is 0. So even you could check each of them, which is, let's to check the entrance. So the first car goes there, second cars go there, 3, 4 and 5. So as you see, we have 5 cars and these red is full. If I just pass one goes out, which I'm going to move my fingers around the sensor, so see it's actually is available. So I hope you like this video. Thank you for watching.